Hello friends, welcome to HP Mathematics Academy. In the last lecture we have discussed up to question number 35. So we will discuss question number 36 onwards in this particular lecture. So let's start our discussion. Let us solve these questions. So we have in the first question it is given that prove that curl of phi times of gradient of phi is equal to 0. So let us start discussing these questions one by one. We have the first question, we have to prove that the question number 36. So we have to prove that curl of phi times of gradient of phi is equal to. Okay, so let us solve this. So let us take gradient of phi as, let's take let gradient of phi is equal to a vector. Okay, so we have curl of phi times of gradient of phi. The gradient of phi is a vector. This is, so we have studied the expansion of curl of phi a. Curl of phi a is del phi cross a plus phi times of del cross a. Okay, let us apply this. This is equal to del cross phi a equal to del phi cross a plus phi times of del cross a. This is equal to del phi cross a is gradient of phi plus phi times of curl of gradient of phi. This a is gradient of phi. This is curl of gradient of phi. Okay, curl of gradient of phi, and curl of gradient of phi is 0. We have already studied. So this is del phi cross gradient of phi is del phi. Cross product of the same vector is 0. This is equal to 0 because cross product of same vector is okay. So the result is 0. Let us discuss question number 37. Let us discuss question number 37. Okay. So we have, if f and g are two scalar point functions, prove that. So it is given that f and g are scalar point function. Okay, so we have to prove that divergence of f of del gradient of g equal to divergence of f times of gradient of g is equal to f times of del square g plus del f dot del g. Okay, how we can solve this? So we have, let us solve this. So we have gradient of g equal to I times of del g upon del x plus j times of del g upon del y plus k times of del g upon del g. F times of del of g equal to f times of del g upon del x I cap plus f times of del g. We have f times of del g upon del y to j cap plus f times of del g upon del z j cap. Okay, this is f times of del g. So we have the divergence of f times of del g equal to del upon del x of this expression, del upon del x of f times of del g upon del x plus del upon del y of f times of del g upon del y plus del upon del z of f times of del g upon del z. Okay, let us expand this by using differentiation using parts. So this f times of del 2 g upon del x plus del f upon del x times of del g upon del x. The expansion of this first term plus similarly this is f times of del 2 g upon del y square plus del f upon del y into del g upon del y. Okay, plus this is f times of del 2 g upon del z square plus del f upon del z into del g upon del z. Okay, Let us combine this. So this we can combine this one, and this is f times of, you can write as del 2 upon del x square plus del 2 upon del y square plus del 2 upon del z square times of g, plus this we can write as I times of del f upon del x. This one we have this one del f upon del plus I times of del f upon del y, sorry, j times of plus k times of del f upon del dot product with this one del g upon del x, del g upon del y, and del g upon del I times of del g upon del x plus j times of del g upon del y plus k times of del g upon, this is equal to f times of del square g plus this is nothing but del of f, this is nothing but del of plus del f dot, this is divergence of f times of, समझ में आ रहा है? Now let us discuss question number 38. Let us discuss question number 38. A vector function f is the product of a scalar function and the gradient of a scalar function, so that f dot curl of f is equal to 0. Vector function f is the product of a scalar function, a gradient of a scalar function. We have a vector function f is product of scalar function and gradient of a scalar function, gradient scalar function, so that f dot curl of f is, so that f dot curl of f is equal to 0. Okay, so let us take two scalar functions. Solution. Let us take two scalar functions psi and phi. We have the f. So we have a vector function. F is the vector function. Vector function. Vector function f is the product of a scalar function and gradient of gradient of scalar function. Gradient of f is the product of psi and gradient of phi. So we have to show that f dot curl of f. We have curl of f is curl of psi times of gradient of phi. Let us take gradient of phi as a. Let gradient of phi is equal to a. Curl of psi a equal to del of, sorry, curl of psi a. Curl of psi a. Have curl of f is equal to, the expansion of this will be del psi cross a plus psi times of del cross a equal to del psi cross, and a is gradient of phi, so del phi plus psi times of del cross gradient of phi, and we have curl of gradient of phi as curl of gradient of phi is equal to, we are left with del psi cross del phi. This is curl of f. Now we have f dot curl of f. F dot curl of f equal to, f is psi times of gradient of phi. Psi times of gradient of phi dot curl of f del psi cross del phi equal to psi times of gradient of phi dot del psi cross del phi. This is nothing but scalar triple product. This is psi times of gradient of phi, this first vector, and we have del psi, and we have del phi. This is nothing but a scalar triple product, and scalar triple product having two vectors as same is 0. So these two vectors are same. Okay, so this is scalar triple product. This is equal to 0 because scalar triple product having vectors as same. Okay, now let us discuss question number 39. Let us discuss question number 39. Okay, question number 39, we have to prove that del dot r times of del 1 upon r cube equal to 3 upon r4. Okay, how we can solve this? Let us find gradient of 1 upon r cube. This is equal to differentiation of 1 upon r cube. This is minus 3 upon r4 times of r vector upon r dot r vector upon r equal to minus 3 upon r5 r vector. Okay. We have r times of del 1 upon r cube equal to r times of minus 3 upon r5 r vector equal to minus 3 upon r4 r vector. Okay. Now we have del dot, that is divergence of minus 3 upon r4 r vector. Let us take this as phi and this as we have the divergence of phi a equal to del phi dot a plus phi times of del dot a. Let us apply this. This is equal to, this whole expression is equal to del of minus 3 upon r4 dot r vector plus minus 3 upon r4 in del dot r vector. This is equal to, let us differentiate minus 3 upon r4. This is 12 upon r5 minus 3 into, this is minus times of r5 r vector upon r dot r vector minus 9 upon, this is 3 times 3 9 upon r4 equal to 12 upon r to the power 6 into r square minus 9 upon r4 equal to 12 upon r4 minus 9 upon r 3 upon r. Okay, this is 3 upon r4 that we have to prove. Let us discuss question number 40. Let us discuss question number 40. Prove that a dot del 1 upon r equal to minus a dot r vector upon r cube. How we can solve this? So we have del upon 1 upon r, del of 1 upon r equal to differentiation of 1 upon r, this minus 1 by r square into gradient of r, this is r vector, s upon r vector upon equal to minus 1 upon r cube r vector. So we have a vector dot del of 1 upon r, a times of a dot minus 1 upon r cube r vector equal to minus a vector dot r vector upon r. समझ में आ रहा है? Basically, we are using the formula gradient of f of r is equal to f dash r del of r. Del of r is r vector upon r. F dash r into r vector upon. Here we have taken f of r as 1 upon r. So f dash r is minus 1 by r. So from here we have del of f of r is equal to, let us put f dash r. So f dash r is minus 1 by r square, r vector upon r, minus 1 by r cube r vector. समझ में आ रहा है? This will be equal to minus a times of r vector upon r cube. Let us discuss question number 41. Question number 41. We have to prove that divergence of a cross r vector equal to r dot curl of a. Okay, so we have studied the identity divergence of a cross b equal to b dot curl of a minus a dot curl of b. So let us take b as r vector. We have divergence of a cross r vector equal to r vector dot curl of a minus a times of a dot curl of b. Curl of is r vector. We have curl of b, that is del cross r vector is equal to 0. This we have studied. So curl of r is 0. This is, we are left with r vector dot curl of a. We have divergence of a cross r dot curl of. We have discussed up to question number 41. So we will discuss further questions in next particular lecture. Thank you.